Okay, so there is actually one more example that I want to review for those of us that weren't here today, that is Thursday. So let's take, for instance, something that looks like sine of 3t is equal to root 2 over 2. And let's look for solutions from 0 to 2 pi. Now, this looks a lot like what we've done before, but there's something wrong with the inside. There's something going on here. Normally, we were used to just something like sine of a is equal to root 2 over 2, and we were able to solve that. Well, there's nothing stopping us from just doing this substitution, saying, well, let a be equal to 3t. Now it's a problem that looks a lot like the stuff that we're used to solving. However, again, we are now wanting to solve sine of a equals something, but our domain is in terms of t. So we need to rewrite our domain in terms of our new question. Well, again, this is 3t. So a is equal to 3t. So in order to get this thing in terms of a, I need 3t in the middle here. So what do I do to t to get 3t? I just multiplied it by 3. So I need to multiply all parts of this inequality by 3. Well, 0 times 3 is 0. 2 pi times 3 is 6 pi. So really, my question is, find all solutions for sine of a equals root 2 over 2 in the interval where a is between 0 and 6 pi. Well, first, let's just consider the standard interval from 0 to 2 pi. We should get two answers. Look at our unit circle. That's pi over 4 and 3 pi over 4. So these would be our answers from 0 to 2 pi. But this interval is literally what we did to get this is multiply by 3. This is 3 times as many answers. This is 3 periods. So because each period has 2 solutions and there's 3 periods, we need 6 answers in total. We need 2 answers from each period. Well, how do I move forward one period? I just add 2 pi. So that's for my next period. And then again, I'll add 2 pi, which adding 2 pi twice is just adding 4 pi. And there's nothing stopping us from simplifying these operations, from figuring out exactly what fraction that this is supposed to be, but there's no reason that we have to even. Well, are we done? Did we find the answer that it asked us to? We found solutions for A, but it didn't ask for solutions for A. It asked for solutions for T. So we need to remember A is equal to 3t. So I want just t is equal to something. So how do I get t by itself here? I divide by 3. So that means I need to divide all of these answers by 3. So my answers are pi over 4 divided by 3, 3 pi over 4 divided by 3, pi over 4 plus 2 pi divided by 3, 3 pi over 4 plus 2 pi divided by 3, pi over 4 plus 4 pi divided by 3, and 3 pi over 4 plus 4 pi divided by 3. So this is our answer here. These 6 values are what we get for t. So the general process with this isn't really special based around the fact that this number was 3 right here. If I just gave you any sine or cosine of some integer k times theta, then this whole process would look a lot more alike. All that really changes is just how many periods we're going to be looking in for our domain for A, and then what we divide our answers by, which is just going to be that k there. So we divided all of our answers by 3 on the previous. So now we divide all of our answers by k to solve for theta in this case. And similarly, if I would have adjusted the inputs like this as the example in the workbook, what if we had sine of theta minus pi over 2? Well, again, I would have been fine if I had sine of A, so I can just let A equal theta minus pi over 2. And now we make this kind of adjustment to our domain. Instead of being some multiplication type thing, I need to subtract pi over 2 from my domain and look for answers there. Okay, so that is pretty much every kind of question from chapter 10 or 11, I think. Yeah, 11. Very good. Y'all, I don't know why I said very good. I didn't mean to say that about my work, but I don't know what else I'd be saying it about. I act as if I'm talking to y'all in the classroom right now as I do this kind of stuff. So I try to be like, very good. We made good progress, but I'm talking to my own iPad alone. So very good me, I guess. I don't know. Anyway, yeah, that's it. Goodbye.